All right. So let's move on to the next part. Liana, the areas of parallelograms yes, you may write this. I'll take it here. The areas of the parallelograms on the same base and between the same pair of parallel lines. Okay. Akasha, can you hear me?
Yes, sir.
All right. Some students seems like they lost power. Me too. I don't have power at the moment. Anyhow, right. Okay. Now, basically, if you consider a figure like this, figure one that was in the text book. Let me take it here. Right. Now, if you look at this figure, right? Yeah, many of the students has lost power. Okay, now let's consider the perpendicular height in between the two parallel lines AB and DE to be as h. All right, and the length from A to B as simple b. Okay, so then we can write an equation for the area of, we can use an equation to find the area of ABCD, right? What happens? Base into the perpendicular height. So what is the base of this ABCD? It is AB and the perpendicular height BH, right? If you want to write it in the symbol form, B times H, right? And then if you consider the area of the other parallelogram, who's that? Area of ABEF equals, or it is also equal to the base times the perpendicular height, no? Okay, so the base is nothing but AB and the perpendicular height is simple h. All right, so the length of B is and AB is equal to h, and this is also the same. Now, what can you see a relationship about this, right? What can you see if you consider them as an equation, right? That means the area of ABCD is equal to B times H, and the area of ABEF is also equal to B times H. So what can you say about them? They all equal to the same quantity, isn't it? So by using the axiom 1, what can you decide? Axiom 1 එකට අනුව එහෙනම් මේ area එක එයාට සමාන වෙලා තියෙනවා, මේ area එකත් එයාටම සමාන වෙලා තියෙනවා. එහෙනම් what can you say? Therefore, the area of ABCD will be equal to the area of ABEF. Can you understand? So we can prove it in that manner as well. So there is a theorem that is associated with the parallelograms which having the same base and which are in between the same pair of parallel lines. That is, if the two parallelograms are having the same base and they are in between the same pair of parallel lines, the areas of them are equal. Is that clear? Right? If a pair of parallelograms are in between the same pair of parallel lines and they have propagated or they have originated from the same base, the areas are equal. Can you understand? So that's what the theorem it says. All right. Leander, Yati, consider the following. Consider the following two parallelograms. Consider the following two parallelograms. Right? මෙතෙන්ට එක රූපය ඇඳ ගන්න. ඊට පස්සේ ලියන්න we theorem එකක් තියෙනවා මේකට කලින් ලියන්න. මේ රූපය අඳින්න. Consider the following two parallelograms කියලා theorem ලියන්න එපා. Wait. Don't write a theorem. රූපය අඳින්න විසරොම. මේ කොටස ලියන්න එපා. Wait. නෑ කතා කරනවද ඔය? All right. So now, have you finished drawing this? Then write in the figure. Consider the triangles ADF and BCE. ADF and BCE. Right? Now these two triangles, right? What I'm going to do here is make them two congruent. I'm going to show them that these two are equal in area in another particular manner. Okay. So let's check whether that. How to show that these two are congruent? Any idea? හරි. අපිට පුළුවන් මේ triangles දෙක congruent කරන්න under the case of SAS. Right? How? Right? Now if you consider the parallelogram ABCD, right? Now this side will be equal to this side, isn't it? මේ දෙන සමානයි නේද? Let me zoom it in. Right, now if you consider these two lines, they will be equal, right? And if you consider the parallelogram ABEF, this line will be equal to this line. Now the two sides are equal, and then to make it equal to congruent, there should be an angle in between. These two angles are equal. Why? Because these two lines, or the angle DAF and CBE lies in between the same a pair of two parallel lines, right? Therefore, these two angles are also equal, so that we can show that the two triangles are congruent, right? Okay, so let's check whether what we can do by using this congruency. All right, so you can write AD will be equal to BC. What is the reason? Opposite sides, you may write, if you write opposite sides of a parallelogram. Opposite sides of a parallelogram. ඊළඟට AF side එක සමානයි BE side එකට, the same reason, opposite sides of the parallelogram. Okay, now the remaining part is showing the two angles equal. So how can we do that? Yes. How can you show that? We can say that these two angles. Now let me draw it in the color. When මේ angle එක මෙන්න මේ angle එකට corresponding වෙනවා. එහෙම නැත්නම් ඊළඟට මේ angle එක, let me draw it in the color black එක. මේ angle එකට corresponding වෙනවානේ. මේ දෙන්න corresponding. මේ green එක නා corresponding. මෙයා and මෙයා. What is the reason? These two are parallel and these are parallel. Once you subtract these two, these angles will be equal, right? So you may write that, that's enough, because මේක මතක තියාගන්න ඕනේ නෑ ඔයගොල්ලෝ. So I will write it since you want it. So that DAF angle එක සමාන වෙනවා CBE angle එකට. The reason is DAF angle එක සමාන වෙනවා DAF and CB, you need to have a letter here. මොකක් හරි අකුරක් දාගන්න A B C D E F G වගේ දාගන්න මේ figure එක. CBG and අනිත් එක්කන කවුද? FAB and EBG are corresponding angles. එහෙනම් කියන්න පුළුවන්, therefore the triangle ADF is congruent to the triangle BCE under the case of SAS. Okay, so these are congruent, right? Congruent කරාට පස්සේ බලමු මොකද කරන්න කියලා ඊළඟ. Now I'm going to write an equation for the area of the parallelogram. Area of A, B, C, D will be equal to the sum of area of the trapezium. එකක් තියෙනවා බලන්න A, B, C, F ඊළඟට plus area of the triangle AFD. Okay. ඊළඟට area of අනිත් එක්කෙනා AB EF will be equal to sum of area of the trapezium ABCF